Okay, let's do lab 9. Lab 9 is a regenerative circuit, or we call it a regen circuit. Now, the regen circuits are pretty cool. Let me kind of explain to you a little bit about why we would want a regen circuit. So I'm going to paint a picture for you. Imagine a manufacturing plant that's doing stamping, okay, or they've got a mold. However it is, they've got this big machine that's coming down quickly and raising and going up and down and up and down. So there's a certain speed at which it goes down and a certain speed at which it goes up. Now, if we can increase the speed of the movement going down, then I'm decreasing the time it takes to move up and down. So in this case, I'm actually saving money. Why am I saving money? Well, time is money. But if I can save 10% or 15% of time for my stamp coming down or my press coming down or my mold being closed, whatever it is, that movement, if I can speed that up, I'm saving time. If I can speed it up by 15%, I'm increasing my production by 15%, which means that I'm actually creating profit because I'm shaving time off. Okay, so speed is really very important. So what do? Well, we just get a bigger pump. We get a really bigger pump, and then we have to actually go and buy bigger hoses, bigger connections, and bigger valves. Oh yeah, so this is actually becoming a problem. The other thing is that we actually need bigger tanks as well, and we need a much bigger tank because we have to triple the size of the tank depending on the flow rate. You'll learn that in lecture. So what I'm saying here is that it's a real problem. It's actually really expensive to increase the speed of a hydraulic ram. But there's another way to do it that's actually really cheap. We put a regenerative valve in. So a regen valve does something really cool. I'll try and explain this kind of just pointing at some things here. Imagine the flow rate going into here, making this move. Okay, so my flow coming out of here, I'm just going to send it to tank, right? So it's just going to go out to tank. But wouldn't it be nice if I could send it back into here? So I'm going to put a valve in this circuit, so my flow is going to come into here, it's going to come out of here, it's going to come out of here, and instead of going down to the tank, it's going to go back in there and flow this way. So let's actually look at some numbers. I get a flow rate going in there of 3 gallons per minute, let's just say. So we know that the volume in here is smaller than the volume going in because on my rod side I've got less volume. So my flow rate coming out of here is not actually going to be 3. If I have 3 coming in here, I may have 1 coming out here. But if I take this 1 and I put it back in there, now I have a flow rate into there of 4. That's pretty cool. And that speeds your ram up. So it's going to move a lot quicker. Now, it actually creates a bit of a problem when this thing gets all the way to the end, because if I'm regenerating this fluid, I'm not actually going to generate much pressure or much force in here. So what we do is we shut our regen valve off when this thing extends all the way. Now, there are a few different ways that we can do that, but we won't talk about how to shut it off or turn it on when we need to have it on and off. That is a control thing that you guys can figure out with either some other kind of pressure sensor that's going to switch your valve, or maybe some kind of limit switch. But we're not going to focus on that. We're just going to see a regen in action. So we're going to hook this thing up normally, watch its speed, and then we're going to hook a regen up to it, and we'll see that it goes a lot quicker. Let's hook up the lab. So I'm starting with my basic lab. I'm going to use my DCV. I'm going to put my circuit over here. And what I'm going to do is I'm going to hook up a normal circuit. So I'm just going to watch it move and study it. Then I'll put the regen in, and then we'll see it move quicker. Also talk about a little bit more about the regen as when we hook it up. But right now, I'm just going to hook up my standard DCV connections. I want my power, and I want my tank. And I'm also going to hook up my pressure so I can study my pressure. I'm going to check for drains to see if I have to hook a drain up. I'm going to hook that up, and then I'm going to start into hooking this circuit up. Okay, good. So now, do I have any drains? Nope, no drains. I'm going to hook this up the way the fluid is flowing. So in this case, what I'm doing is I'm studying the fluid going into my cylinder. So I'm going to start coming out of my DCV and going into my cylinder, and we'll see what's going on. Okay, the first thing I'm going to do is I'm actually going to go into here, and then I'm going to come out of here, and I'm going to go into there. But to do that, I also, because I'm using this, I also need to put a check valve in parallel with this guy. So right away, I'm just going to put these on here. Good. I've got these guys going on. Now I'll continue my circuit. I'm going to hook it up the way the fluid flows. So I'm going to come out of here. And I'm going to go into this guy. Now my flow is going this way, so that's how I'm going to hook it up. Okay, good. So now I have my flow come out of here, and you know what, I can see that it's going to come out of here, and I also have a meter over here, so I'm just going to take this guy and put that on there and connect the hose between the two of them. Here we go. So my output of here is going to come over to here and go in here. Good. And now I'm going to put my check valve in. Okay, good. So I'm going to hook my two ends up to here. And then when I hook my check valve up, I'm going to pause and stop and make sure I hook it up the right way. Okay, good. So now here's the pressure side going into here. So from here, that's going to see the ball side. Okay, so I'm going to put this on my ball side. Good. And my other line here, coming from my other side, is going to go to this side. Sweet. So now I'm going to check to see I got everything hooked up to my circuit. Oh, I've got one line to come out of here to go back to my DCV. Sweet. Always make sure that all of your lines are hooked up before you turn the circuit on. Okay, here we go. Going back to my DCV. Okay, good. I've got everything hooked up. Let's turn it on, press play, and watch what's going on. Okay, so we're going to turn my circuit on, and I'm going to study the flow rate, or more specifically, I'm going to really watch that cylinder. I'm also going to study the flow rate. So I'm going to turn this on slowly. We're good. Now I'm cranking up to 500 for this circuit. You can just run it right at 500. Okay, there we go. So now let's watch my cylinder move, and we're going to study the flow rates. Okay, here we go. Okay, so I've got a high flow rate of 3. Okay, so now what I want to do is just kind of watch that one more time. I've got 3. Now watch the speed of the cylinder. Okay, it's going at a certain rate. That's good. Now let's actually change this around so that we're actually using a regenerative circuit, and we'll see that it goes a little faster. So I'm going to retract it all the way. Again, one more time I'm going to watch it, and I've got just under 3. We'll see what I can get out of it if I put it into a regen. I'm going to shut it down. Now I'm going to rehook it up for a regen. So let's take a look at the regen. So what we're going to do with this regenerative circuit is we're going to hook it up not exactly like a regenerative valve is hooked up. Take a look at this picture. You can see here that we've added an extra valve. And take a look at how the flow is actually coming out of the input and actually going into the cylinder, now coming out of the cylinder, and then going back into the input again. So it's going through that valve, but only if we activate that valve. As you can see, if I deactivate this valve, and if I were to run the circuit, it would run just normally. So I have the option of activating the regeneration or not activating the regeneration. So in this case, we're not hooking that circuit up because we don't have a regenerative valve, but we can study the same thing by hooking it up like this. Yeah. So if you see that, it's very much like a regenerative valve, and that the fluid that's coming out of my cylinder is actually just going back into the pressure of the DCV, and then it's being distributed into the extension of the cylinder. So we'll see that when we hook it up like this, the flow rate will be greater. This is really no different than using an actual regenerative valve, except it's a little bit difficult because we have to unhook it just to make the cylinder retract. But let's go ahead and hook this circuit up. Okay, so now we're going to do part 2 of this, where we're going to hook it up for regeneration. But to do that, take a look at the different valves. Before, I had this valve, and now what I'm going to do is I'm going to do a lever activated valve, but more specifically, this is different because the centers are different. Take a look at the two. This is what we used before, and this is what we're using after. The centers are different. It actually makes the circuit a little bit more tricky because we have to do kind of a strange thing to the DCV to get pressure. You'll see that in action when I hook it up. But my point here is that actually we have to use a different DCV to make this happen. Okay, good. So let's actually hook the other DCV up. So I'm going to undo these and put them on over to here. I'm going to transfer everything over to here. I won't hook everything up exactly how it is. I'm going to leave this here. Actually, we can see right away that I've got to put a T in here. So I'm going to grab my T, and in my pressure, because I want this line here to return into here, I'm putting a T here. Okay, good. So that's there. What I'm going to do is I'm going to hook up pressure here first. So I've got my pressure line coming in here. Okay. Now I've got this line coming in here. So this is regenerating back into the pressure of this valve. It's going to come out of here. It's going to come out of here and go back to the cylinder. Okay, good. So now let's continue hooking this up. I'm going to hook up my drain over here. And I'm going to switch this guy over to here as well. And I can see that this goes into my A port, so I'm going here. So now, gets a little tricky here because I can't build up pressure. Look at this circuit. If I were to have it in the center position, and if I were to turn the pressure on, you can see the fluid just goes right in pressure and it goes straight to tank. So what I'm going to have to do is actually activate the valve so that I can adjust the pressure to 500. So let's go through that process. And I will actually fire this thing up and we'll see that I can't increase the pressure until I activate this valve. I'll put it up to 500. Oh, it's not going to 500. It's because it's just going through the valve. So I'm going to do this and I'm going to activate my valve. Now I've got a couple options. One is I can activate it to extend or activate it to retract. It doesn't matter as long as when I activate it, either the cylinder is stopped or it's not moving. So I'm just going to do this, and that means I'm activating port B, which is not being used. And now I'm actually going to crank this up, and we'll see the pressure go up. Sweet. I've got 500 psi coming up. There we go. I'm at 500. I'm going to release this, and we'll see the pressure just drops because it's going to tank. That's okay. Now I have my regenerative hooked up. I've got my flow meter hooked up. I'm going to study the flow, and we're going to see it's going to jump up quite a bit. Check it out. Look at that. I'm over 4. Now I'm going to retract this. Some of you may be thinking, wait a second. This is not hooked up. This is for retraction. Well, it actually will retract, and the reason it will retract is because this thing, when I retract it, it will see a little bit of the tank. Actually, it will see a high pressure of the tank. Although the fluid going in here sees the tank because it's actually venting because of the nature of the valve, but it will see some pressure and it will retract. Check it out. There you go. So it's actually fully retracted, and we can do this again and watch this. There we go. Nice. And in retraction, it still works in retraction. Perfect. Now you guys are experts at understanding what regen or regenerative flow is when we hook up a regen circuit, and you know what it's about. You know, we've studied the application of it, and we've seen how the flow can come out of here and go back into here and make that flow more quickly. When you actually see this in industry, or when you're actually hooking it up for real, you're going to see that you'll have a special and separate valve just for regeneration.